Today we're talking about inverses. When we talk about inverse of a function and what it means and what it looks like, I'm going to talk about some vocab here first of all. When I do an inverse, I'm simply going to interchange the first and second coordinates of each ordered pair. And a lot of times I'll probably just say switching x and y, because that's essentially what we're doing. But the reason we use this definition is because it may not always be x and y. Maybe the ordered pair is representing something else. So we're just going to take the ordered pairs and we're going to flip-flop them. And so if I gave you an example here of a set of ordered pairs, doesn't really matter how many ordered pairs we have here. We have 4 different ordered pairs. And so when I write the inverse of H, all that happens is the x and y just flip-flop. Okay? Nothing happens with the signs or anything else. And I threw some different ones in here just so you kind of see even decimals. Decimals don't change anything. So this would become, excuse me, 5 negative 8, negative 2 4, 1 negative 7, 6.2, 3.8. And that's my inverse. Okay, so ordered pair is pretty straightforward. If I wanted to do that for an equation, equation is going to have basically the same idea. If my original equation is y equals x squared minus 5x, the inverse, we're going to do basically the same thing we did with the ordered pairs. We're going to make the y's become x's and the x's are going to become y's. So when I rewrite this, I'm going to say x equals y squared minus 5y. And that is simply just what we call the inverse of that equation, just switching the x and y's around. In some cases, what we'll do is we'll do a little bit more work with this and try to determine if it's a function or not, and we'll talk about what a function means. But in this case, we just want to write an equation of the inverse. And then we'll talk about a little bit more today of what that inverse really means and what we can do with it. Okay, a couple of different things that I'm going to give you some pieces of information here, and then we're going to talk about graphs of an inverse and its original function. So first of all, a function is one-to-one, and I kind of like to use like abbreviation of one-to-one rather than writing it out in words. We'll say one-to-one a lot when we talk about inverses. So a function is one-to-one if all x and y values are different. Okay, and so what that basically means is when we talked about if a function, if a relation is a function, all of the x values had to be different, right? But now we're saying the x and y values both have to be different. So both x and y must all be different in order for the new one to be a function, in order for it to be a one-to-one function. The second thing we're going to talk about, if the inverse of a function is also a function, then we will name it f inverse. And that would be the way that we read that. Not f to the negative 1 power. We read that as f inverse. So that's the terminology or the lingo that we're going to use when we talk about an inverse. But that's only if it's a function. And so that means that the original is a function, my new one is a function, so we can call this a one-to-one function. The negative 1, even though it looks like an exponent, we don't read it as f to the negative 1. We just read it as f inverse. When we try to determine if a graph is a one-to-one function, there's some different things that we're going to do. If the inverse of a function is also a function, then we're going to name it f inverse. And so on this one, what we're going to actually do is we're going to solve the equation if I gave you a linear equation. When we asked, is this a function, way back when, in order for this to be a function, it had to pass the vertical line test, which means as I run my pen across here, I'm only going to touch one point at any given time, okay? And that told us that it was a function. Well, in order for this to be a one-to-one function, not only is it going to pass the vertical line test, but it's also going to pass the horizontal line test, okay? So as I run my pen down horizontally, in addition to vertically, it's only going to touch one point at any given time. And so we would say that yes, this is a one-to-one function. Because it passes the vertical and the horizontal line test. If I give you another one here, let's say we have parabola, okay? And we've seen parabolas a lot as we've gone throughout the year. So this one, it does pass the vertical line test, right? So it is a function. A parabola is a function. And that's one thing that we talked about way back when we talked about parabolas and functions, and this one would be a function. But when I do the horizontal line test, then I touch more than one point horizontally. Okay, not vertically. Like any point that I stop vertically, I'm only going to touch one point. But when I do the horizontal line test, I touch more than one point. And so this one is not a one-to-one function. Because it doesn't pass the horizontal line test. I'm going to give you one more here of a graph and just trying to determine if it's a one-to-one function. This one's maybe a little bit tricky, and we've seen some graphs like this. In the last chapter, we saw some graphs like this that had a curve, okay? And in this case right here, it's approaching the x-axis, and we said that the x-axis is its asymptote, okay? And it also looks like it's approaching a vertical line as well. Is this a one-to-one function? So vertically, am I touching more than one point at any point in time as I move my pen across here? No. Okay, so it is a function, okay? Now we want to know, is it a one-to-one function? So as I move my pen, if I stop my pen right here, am I touching more than one point as I go up and down? This is where it gets a little bit tricky, right? Because this graph looks like it flattens out, and so it looks like it's going to be the same value. But what happens on an asymptote is it gets really, really close. It just keeps getting closer and closer to the x-axis and never actually touches it. Now, is it changing by much? No, okay? But it is gradually getting closer and closer by maybe like hundredths of a point. But it is getting closer and closer to the x-axis. So even though it kind of looks like it's eventually going to get flat and it wouldn't pass the horizontal line test, it actually does. So anytime you see something like this that has an asymptote to it, then it would be a one-to-one function. But this one I think is probably the one that's the trickiest out of all of them. Because it has asymptotes to it. Okay, so all we're doing on something like that is give you a graph, and you're just trying to determine, is it a one-to-one function or not, just by the looks of it, and does it pass those tests. Okay, I'm going to give you a couple of different examples here of some graphs that we're going to do. To what I said over here. So in this one, we're going to graph the original, and we're going to graph the inverse on the same graph. So my original function that I'm going to give you is y equals x squared plus 1. And we should already kind of know that it's a parabola. You can use your graphing calculator to graph it if you really need to, okay? We should already know it's a parabola, though. And I'm going to put both of these on the same graph. Okay, this is my original. And so what I would probably come up with here is just come up with a list of ordered pairs that we could use here. So 0, 1 would be a point. Okay, and then I'm going to pick a point to the left, and I'm going to pick a point to the right. Okay, and I kind of skipped over 1 because 1 doesn't move very far. So I'm just picking a little bit bigger number. So I'm going to go to 2. 2 squared is 4. 4 plus 1 is 5. And you could come up with those numbers from your calculator as well. Okay, that is our original graph. Hey, now if I was going to graph the inverse, the easiest way to do that is the equation is going to be x equals y squared plus 1. we're just going to switch the x and the y around, right? X becomes y, y becomes x. And I can't really solve that equation for y, like most of the equations that we're going to have, because it has a squared on it. And so the easiest way to graph this would be to take the 3 order pairs that I have, and that's why writing out the table of values is helpful, and then just switch the order pairs around. So this would become 5, 2, 1, 0, and 5, negative 2. So if I graph these, it takes that parabola and it kind of lays it over on its side. And just so you kind of understand what's going on here, the line of reflection here that we talked about all the way back in geometry is what we call the y equals x line. This line right here is the line that I'm reflecting over. This point up here reflects here. This point here reflects here. This point here reflects all the way down here. So it's reflecting over that line. And you don't necessarily have to do the reflection itself, but just so you kind of have a visual of, does it look right? Does it match up? This parabola is being flipped over that line. That's what we call the line of symmetry. This line right here, the reason we call it the y equals x line is because on this line, y and x are equal to each other. So points that would be on this line would be 1, 1, 2, 2, 3, 3, 4, 4. All your x and y values are the same. And that's the line that's being flipped over. If you have a point that lands on that line, it's not going to be flipped, right? If I have the point 4, 4, that point doesn't get moved. And sometimes when you look at these graphs, you will have a point that falls on that line of symmetry, and so you don't have to move it at all. Okay, if I go back to the original one, and I say, is this a one-to-one function? We would say no, right? Because originally what we said, it is a function because it passes the vertical line test, but it doesn't pass the horizontal line test. And the reason why it's not a one-to-one function is because my new graph down here is not a function, okay? If this was a linear equation, then both graphs would be functions. Both the original and the new one would be functions. They would both pass the vertical line test. So this one passes the vertical line test, this one does not. So that's why this one is not a one-to-one function. Okay, but you wouldn't necessarily have to graph it to determine that. That's why we do the horizontal line test. So it kind of depends on the question that's being asked. Are they wanting us to take a look at the graph? Some of them will ask you to do that today. Others are just going to simply ask you, is it a one-to-one function? And you don't have to do the whole graph and all of that. Okay. The other one I want to show you here. I'm going to go back. We're going to do the same thing we just did. Okay, this is my original function. We're going to graph the original. And then we're going to graph the inverse. Okay, and I'm going to leave it like that for right now, but I'm going to show you the way that we're going to write this one. Because if I graph this, and once again, I'll keep telling you this, but you can definitely use your calculator for this, right? I can graph y equals 3x in my calculator. I can go to my table of values and I can get some points. So I could do -1, 3. I could do 0, 0. And I could do 1, 3. There's my original graph. Okay, pretty basic, just basic old linear equation. Has a slope of 3, has a y-intercept of 0. All of those things are holding true. Over here, if I wanted to graph this one, This one, oops, 3, -1. So we would go 3, -1, and 3, 1. Oh, this should be a -3. That's my fault. Okay. Kind of screwed that one up. Okay, so over 3 and up 1. And then -3, -1. Okay, and once again, this line that goes right down the middle, and I only show you this just so you can kind of get a visual of, does it look right? And sometimes they're just going to give us a graph, and I just got to take those points and flip it over. But once again, I can see how these points, notice here how 0, 0 is on the original graph, and so it doesn't move at all, right? And then those points would flip as well. So the original graph is my red graph. Is it a one-to-one function? Does it pass both the line tests? Absolutely, right? It passes both vertical and horizontal line tests. My new one is also a linear function, so it's also going to pass both line tests. So it would be a one-to-one function. When it is a one-to-one function, for y, we're going to rewrite the equation. So I have x equals 3y. And so to finish this out, we're going to divide by 3, or I could write it as 1/3 x. And the way that we're going to write this, the equation of the inverse, we would say f inverse is 1/3 x, or x over 3. Okay? And this is the terminology that you're going to see written quite a bit, just so you get in the habit of seeing that and using that. So basically, the operation has just undone itself, right? If I had x plus 2, the inverse would be x minus 2. In this case, we had x times 3, so the inverse is x divided by 3. So it changes the operation, it changes the sign a little bit. Okay, I think because of time, I'm going to cut it there for today. If there's some other things that I need to kind of go back through tomorrow, then I'll do that. But that should get you where you need to be for today. I know we were a little bit shorter on time because of the computer thing today. But that should get you really where you need to be, I think. Okay, so we're going by 4s here. So remember this, we're just going to add 4 each time. So 1, 5, 9, all the way up to 41, and then 47 at the end. So if it just asks for an equation, then just flip the x and y and you're done. If it asks for the inverse equation, that's when you'd have to go ahead and solve, especially if it's a one-to-one function. There's a couple on here today where they don't give